When you think about developmental psychology, child development may be the first thing that pops into mind. However, development is in fact a lifelong process. You remain on this very day in the midst of your development, wherever you are in the adult lifespan. Further, as an active developer, you blaze your own developmental trail. Development is an ongoing process that is influenced by the active developer at every point in the lifespan. In adulthood, development can be especially shaped by the ways individuals confront significant life events. Coping with stressful experiences and being open to change can be catalysts for adult development. Developmental psychology includes the scientific study of biological, cognitive, social, and personality development throughout the lifespan. It involves the nature versus nurture question, which begs the question, do our traits and behaviors result from heredity, nature, or the environment, nurture? Both nature and nurture play powerful roles in shaping development, yet disentangling their effects is far from simple, because nature and nurture intersect in a variety of ways. Developmental psychologists typically divide the lifespan into specific stages corresponding to chronological age, but we must be careful as individuals can progress at different rates as they face life events which can affect the progression through these stages. Moreover, the transition between stages is not always clearly evident, but is more likely very gradual. Also, these stage definitions may vary across cultures. As we begin, we must be careful to avoid two myths concerning development. The first is the myth of infant determinism, the widespread assumption that extremely early experiences, especially in the first 3 years of life, are almost always more influential than later experiences in shaping us as adults. There's no question that early experience plays an important role in children's physical, cognitive, and social development, but there's no reason to believe that later experiences play any less of a role in development. In fact, neuroscience research shows that the brain changes in important ways in response to later experiences. The second myth is childhood fragility, which holds that children are delicate little creatures who are easily damaged. Research shows most children are remarkably resilient or capable of withstanding stress, and that most children emerge from potentially traumatic situations in surprisingly good shape. In this lecture, we'll look at prenatal development and infancy, and then how we think throughout our lives, considering how we learn language. We'll look at Piaget's theory and Vygotsky's sociocultural approach to development, and how intelligence changes in adulthood. We'll conclude with the section on moral development and social development, considering Kohlberg's theory of moral reasoning, attachment and parenting styles, the theory of mind, and Erikson's psychosocial stages. I apologize for any flashbacks to a biology class, but human conception begins when a sperm penetrates the membrane of an ovum. When the two combine, a complete set of genetic instructions is formed, half from the father and half from the mother. Every cell of a normal human has 23 pairs of chromosomes, including one of each pair coming from the mother and one from the father. The most dramatic changes in prenatal development occur in the earliest stages of pregnancy. Around the middle of the second week, the cells begin to differentiate, taking on different roles as the organs of the body begin to develop. The human brain begins to develop a mere 18 days after fertilization. Unlike most organs, which are completely formed by birth and continue to grow only in size, our brains continue to develop into adolescence and probably even early adulthood. Humans normally have 46 chromosomes arranged in pairs. It is the 23rd pair of chromosomes that determines the person's sex. For a female, there are 2 X-shaped chromosomes. For a male, 1 X-shaped chromosome and 1 smaller Y-shaped chromosome. It is the Y chromosome that leads to the development of a male. In the first few weeks after conception, male and female embryos look alike. When the Y chromosome in the male embryo triggers the secretion of androgens, the main class of male sex hormones, male sex organs start to differentiate from female sex organs. Low androgen levels in a female embryo allow for the normal development of female sex organs. Sometimes parents have twins, and they have been called a double blessing. But the terms identical and fraternal don't describe what the twins look like, but actually how they form during prenatal development. Identical or monozygotic twins occur when the growing cluster of duplicated cells breaks apart early in development, resulting in two clusters with identical genes. Clusters become identical twins because they come from the same zygote or fertilized egg. Fraternal or dizygotic twins originate from the fertilization of two eggs at about the same time. Consequently, fraternal twins, as well as any two children of the same parents, may vary greatly in appearance. Identical twins, monozygotic twins, are always of the same sex because they form from a single zygote that contains either male XY or female XX sex chromosomes. Therefore, boy-girl twins are always fraternal or dizygotic. They can only form from two separate eggs that are fertilized by two separate sperm. Fraternal twins can be either two girls, two boys, or one of each. Although most babies are born healthy and fully intact, fetal development can be disrupted by nature or nurture. Genetic disorders or random errors in cell division are an adverse influence on prenatal development. Often a single cell, including the egg or sperm cell prior to fertilization, or even a family of cells, is copied with some error or break in the genetic material. Like a page with a smudge that keeps on being photocopied with that smudge preserved, the cells go on to replicate with the error retained, resulting in impaired development of organs or organ systems. Most women don't realize they're pregnant until after the fetus's body and brain development are well underway. As a result, women may engage unknowingly in activities that are potentially harmful to the fetus. Teratogens are environmental factors that can exert a negative impact on prenatal development. They run the gamut from drugs and alcohol to chickenpox and x-rays. Even anxiety and depression in the mother are potential teratogens because they alter the fetus's chemical and physiological environment. For example, alcohol exposure can result in fetal alcohol syndrome, which includes a host of symptoms, including learning disabilities, physical growth retardation, facial malformations, and behavioral disorders. Cigarette smoking during pregnancy is one of the most prevalent teratogens. Depending on the teratogen and when the embryo or fetus is exposed to it, teratogens can influence how specific parts of the brain develop. Others exert a more general impact on brain development. Because the brain has such a long period of maturation relative to most other organs, it's particularly vulnerable to teratogens. Starting at birth, infants learn how to make use of their bodies through movement and coordinate interactions with their environment. Some aspects of motor coordination are evident even at birth, but others develop gradually throughout infancy and early childhood. Infants are born with a large set of automatic motor behaviors or reflexes that are triggered by specific types of stimulation and fulfill important survival needs. One example is the sucking reflex, an automatic response to oral stimulation. If we put something in a baby's mouth, including a finger, she'll clamp down and begin sucking. A related reflex is the rooting reflex, which serves the same survival need, eating. If we softly stroke a hungry infant's cheek, she'll automatically turn her head toward our hand and begin casting about with her mouth, eagerly seeking a nipple to suck. These reflexes help keep infants alive because if they needed to learn through trial and error that sucking on an object yields nourishment, they might starve trying to get the hang of it. Other reflexes disappear as the child gets older. The Babinski reflex occurs when an infant fans its toes upward when its feet are touched. The grasping reflex occurs when an infant grasps any object that touches its palms. But reflexes can only get babies so far. They must learn other motor behaviors through trial and error. Motor behaviors are bodily movements that occur as a result of self-initiated force that moves the bones and muscles. Now, there's an orderly sequence of motor development. First, propping up and supporting the body, then crawling, then standing with support, standing without support, and then walking. Now, the age at which the different children reach these milestones varies enormously, although almost all acquire them in the same order. Motor skills and perceptual skills are coupled and depend on each other. To reach for something, the infant must be able to see it. Babies are continually coordinating their movements with information they perceive through their senses to learn how to maintain their balance, reach for objects in space, and move across various surfaces and terrains. Now, psychologists face a daunting challenge in studying infant perception. Infants cannot talk, so how can scientists learn whether they can see or hear certain things? Well, psychologists have discovered habituation in infants, which is a decrease in the physiological responding to a stimulus once it becomes familiar. Psychologists study infants' reactions to novel or new stimuli and have found that infants tend to look longer at novel stimuli. If infants look longer at a new stimulus than an old one, then it is inferred that they must be able to perceive the difference between the two stimuli. And infants also intensify their sucking of a pacifier when confronted with a novel stimulus. Depth perception appears in infancy. We can judge depth as soon as we learn to crawl. Gibson and Walk established this phenomenon in a classic setup called the visual cliff. They used a visual cliff apparatus to demonstrate depth perception. Young infants would not crawl onto an apparent steep drop-off. Now, Adolph and colleagues later found that locomotor learning experience influenced depth perception. With increased mobility, the increased ability to move around, locomotor experience leads to a fear of heights. Now, this photo shows an infant on the center board of the visual cliff apparatus and his mother trying to coax him to crawl toward her over the apparent steep drop-off, but the infant won't crawl onto the glass. Research has shown that almost all infants ages 6 to 14 months will not do so. Now, as an infant plays, crawls, shakes a rattle, smiles, and frowns, his or her brain is changing dramatically. At birth and in early infancy, the brain's neurons have only minimal connections. The infant brain literally is ready and waiting for the experiences that will create these connections. During the first 2 years of life, the dendrites of the neurons branch out, and the neurons become far more interconnected. Now, at birth, vision is the least developed sense, and within 2 to 3 months, color vision develops. And within the first year of life, visual acuity reaches 20/20. At first, infants don't see very clearly. Now, infants do have a preference for visual complexity, and such stimulation is necessary for the proper development of the visual pathways and cortex during infancy. Hearing is a little different story. Before birth, the ability appears to develop in the womb. For the newborn, hearing is more fully developed than vision. The infant can distinguish their mother's voice from those of others, and by 6 months, the infant's hearing is comparable to that of an adult. One of the most remarkable hearing abilities that infants possess involves speech perception. Phonemes are the smallest distinctive speech sounds in a language, and infants can detect all phonemes with or without exposure to them. A phoneme is a single unit of sound that has meaning in any language. There are 44 phonemes in English, each one representing a different sound a person can make. Since there are only 26 letters in the alphabet, sometimes letter combinations need to be used to make a phoneme. Now, here's a good example. Chef, choir, and cheese. Now, the CH letter combination has 3 different pronunciations, which are represented by 3 different phonemes. Of course, this is confusing when you need to learn new words. Now, by 12 months, infants can no longer detect non-native speech sounds. It seems as though infants come into the world prepared to learn whatever language they happen to find themselves exposed to, and experience fine-tunes this ability. In addition to hearing, the senses of smell, taste, and touch are also fairly well developed at birth. For example, infants can differentiate the smell of their mother from those of other people. And perceptually, very young infants may have an innate conceptual understanding of object movement, according to researchers. For example, they may understand that objects cannot go through solid surfaces. This next section of the lecture covers how we think throughout our lives, and we'll look at how we learn language, Piaget's theory of cognitive development, and Vygotsky's sociocultural approach to development. Language is a vast system of symbols capable of expressing most thoughts. Language is the vehicle for communicating most of our thoughts to one another. Now, although we do not always think in words, our thinking would be greatly impoverished without words. The connection between language and thought has been of considerable interest to psychologists. Now, you'll recall from a previous module that memory is stored not only in the form of sounds and images, but also in words. Language helps us think, make inferences, and tackle difficult decisions, and solve problems. In the initial stage of language development, infants communicate through crying, with different cries for hunger and for pain, and through movement and facial expressions. And infants prefer baby talk, or what's called parentese. It's a different format of speech that adults use when talking with babies that involves the use of shorter sentences with a higher, more melodious pitch than normal speech. Language researchers are fascinated by baby speech, even before the little ones can say their first words. Babbling, endlessly repeating sounds and syllables, such as ba 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 and da da da, begins at about the age of 6 or 7 months and is determined by biological readiness, not by the amount of reinforcement or the ability to hear. Even deaf babies babble for a time. Babbling probably allows babies to exercise their vocal cords and helps develop the ability to articulate different sounds. At about 1 year of age, infants speak their first words, which usually refer to their caregivers and objects in their daily environment. Now, infants use hollow phrases, words that express complete ideas. A hollow phrase is a single word, such as okay, that is used to express a complete, meaningful thought. In studies of language acquisition, the term hollow phrase refers more specifically to an utterance produced by a child in which a single word expresses the type of meaning typically conveyed in adult speech by an entire sentence. Some researchers believe it is the single word in conjunction with the gestures and facial expressions that is the equivalent of the whole sentence. So by this account, the single word is not a hollow phrase, but one element in a complex of communications that includes nonverbals. The next stage of language development involves acquiring vocabulary. And until about 18 months, this is a slow growth stage. About 100 words or more per month are learned then. A child's first words, uttered at around the age of 10 to 13 months, name important people, such as dad, familiar animals, such as kitty, vehicles, such as car, toys, such as ball, food, such as milk, body parts, such as eye. Now, by the time children reach the age of 18 months, they usually utter two-word statements. They quickly grasp the importance of expressing concepts and the role that language plays in communicating with others. To convey meaning in two-word statements, the child relies heavily on gestures, tone, and context. Although these two-word sentences omit many parts of speech, they are remarkably effective in conveying many messages. When a toddler demands "pet doggy," parents know that he means "may I please pet the doggy." Very young children learn that language is a good way to get what they want. Now, two important concepts in this stage are overextension and underextension. Overextension is the application of a newly learned word to objects that are not included in the meaning of the word. For example, an infant calling any female person mama. Underextension refers to the failure to apply the new word more generally to objects that are included within the meaning of the new word. For example, an infant not extending the category of dog to include dogs that are not the family pet. The next language stage is between 18 and 24 months. Here there's a vocabulary acquisition spurt, and words begin to be combined into sentences. Telegraphic speech begins, and as I mentioned, it may begin a little before 18 months for some children. Telegraphic speech is the use of two-word sentences with mainly nouns and verbs, whereas adjectives, adverbs, articles, and connective parts of speech are omitted. For example, dada eat for dad is having dinner. Or a child may say, no mommy, no go sleep. Two-word statements begin to be expanded, and between the ages of 2 and 5 years, the child implicitly acquires grammar of the native language. Now it's considered implicit because children comprehend some basic syntactic rules or rules of grammar before they can display them. Among other things, they understand how word order relates to meaning before they can actually generate these sentences. As you can see, children have a special skill in learning a language, and there is a critical period for acquiring it. A critical period is a time period when learning certain skills is more easily accomplished, and it is thought to reflect the influence of biology or brain maturation on development. Now, both nature and nurture are vital to language development, and if children do not acquire a language by a certain age, it is usually thought to be around the time of puberty or perhaps earlier, then they will not learn it as well as younger children. Now, we do know that language development is a genetically programmed ability. However, nurture is involved because it is not developed without exposure to human speech. The pioneering Swiss psychologist Jean Piaget was the first to present a comprehensive account of cognitive development. He attempted to identify the stages that children pass through on their way to adult-like thinking. Perhaps Piaget's greatest accomplishment was his insight that children aren't miniature adults. He showed that children's understanding of the world differs fundamentally from adults, but is perfectly rational given their limited experience with the world. For example, children often believe that their teachers live at school, a reasonable assumption given that's the only place they've seen their teachers. In his methodology, he conducted loosely structured interviews and posed problems for children to solve, then observed and questioned the responses. And he was particularly interested in children's errors. And he assumed that a child is an active seeker of knowledge and gains an understanding of the world by operating on it. Piaget noticed that children develop schemas, which are organized units of knowledge about objects, events, and actions. And he proposed that cognitive change is marked by maintaining a balance between our experience of the world and our thoughts about it. Children, he said, are motivated to match their thinking about the world with their observations. When the child experiences something new, he or she checks whether that experience fits with his or her schema, his or her understanding of and expectations about how the world works. If that information is inconsistent, as when a child has a schema of the world is flat but learns in school that the earth is round, something must give way. Piaget suggested that children use two processes, assimilation and accommodation, to keep their thinking about the world in tune with their experiences, and he called this cognitive adaptation, which occurs through these two processes. The process of absorbing new experience into your current schema is assimilation. If a child who believes the earth is flat learns that the earth is round, he or she might assimilate this knowledge into her schema by picturing a flat disk like a coin. Now, this adjustment allows the child to absorb this fact without changing his or her belief that the earth is flat. Now, children use assimilation to acquire new knowledge within a stage. Now, during assimilation, the child's cognitive skills and worldviews remain unchanged. So he or she represents new experiences to fit into what he or she already knows. Accommodation is the altering of a schema to make it more compatible with experience. Accommodation drives stage change by forcing children to enter a new way of thinking and looking at the world, in this case by changing their conception from flat to round. And it is through accommodation that the number and complexity of a child's schemas increase and learning occurs. According to Piaget, we go through 4 stages in understanding the world. Each stage involves a qualitatively different way of making sense of the world than the one before it. In the sensory-motor stage, from birth to 2 years, children use senses and motor abilities to learn about the world and develop object permanence. In the pre-operational stage, from 2 to 6 years, children use symbolic thinking to understand the world, but remain egocentric and lack the mental operations that allow logical thinking. In the concrete operational stage, from 6 to 12 years, children gain cognitive operations for logical thinking about concrete events. They understand conservation and perform mathematical operations, but they cannot reason abstractly. And finally, in the formal operational stage, from 12 years through adulthood, further development of cognitive operations enables adolescents to engage in abstract thinking and hypothetical deductive reasoning. And we'll take a little closer look at these stages in the next slides. Piaget's first stage, the sensory-motor stage, lasts from birth to about 2 years of age. In this stage, infants construct an understanding of the world by coordinating sensory experiences, such as seeing and hearing, with motor actions or physical movements, hence the term sensory-motor. Infants lack object permanence, which is Piaget's term for the crucial accomplishment of understanding that objects continue to exist even when they cannot be directly seen, heard, or touched. He believed that out of sight literally was out of mind for very young infants. Piaget studied object permanence by showing an infant an interesting toy and then covering the toy with a blanket. He reasoned that if infants understood that the toy still existed, they would try to uncover it. And in this stage, infants start to develop symbolic representation of objects and events, for example, through the use of telegraphic speech. Piaget proposed that from 2 until about 6 years, children pass through the pre-operational stage, marked by an ability to construct mental representations of experience. Now, children in this stage can use such symbols as language, drawings, and objects as representations of ideas. When a child holds a banana and pretends it's a phone, he or she's displaying symbolic behavior. Similarly, playing house, in which one child pretends to be the mommy and one the daddy and one the baby, demonstrates an ability to assume imaginary roles that differ from actual roles. So children in this stage can pretend, imagine, and engage in make-believe play. Now, although the pre-operational stage sees clear advances in thinking, Piaget believed that children in this stage were hampered by egocentrism, an inability to see the world from others' point of view. They can't distinguish personal perceptions, thoughts, and feelings from those of others. Now, the pre-operational stage is called pre-operational because another limitation is the inability to perform mental operations. Now, although pre-operational children have mental representations, they can't perform mental transformations or operations on them. For example, they can generate a mental image of a vase on a table if the vase isn't there, but they can't imagine what would happen to the vase if someone knocked it off the table. Some other pre-operational stage characteristics are conservation, and some examples of tests for conservation of continuous quantity, number, mass, and length are given on page 303 of the text. And the typical pre-operational child's responses are also given. The liquid beakers problem is a common test of conservation ability. Now, a major reason why a preoperational child does not understand conservation is that the child lacks an understanding of reversibility, the knowledge that reversing a transformation brings about the conditions that existed before the transformation. And a child's thinking also reflects centration, the tendency to focus on only one aspect of a problem at a time. Between 6 and 12 years old, children enter the concrete operations stage, characterized by the ability to perform mental operations, but only for actual physical events or concrete events. Children in this stage can now pass conservation tasks. So the child gains a fuller understanding of conservation and other mental operations that allow them to think logically, but only about concrete events. The child develops transitivity. For example, if A is greater than B and B is greater than C, then logically A is greater than C. Now, children develop seriation. For example, the ability to order stimuli along a quantitative dimension, like sorting coins by size. And the child demonstrates reasoning tied to immediate reality and not with the hypothetical world of possibility. They need physical experience as an anchor. They can perform mental operations, but not in abstract or hypothetical situations. Piaget's fourth and final stage, which he believed didn't emerge until adolescence, is the formal operation stage. It's then that children can perform what Piaget regarded as the most sophisticated type of thinking, hypothetical deductive reasoning beyond the here and now. They can engage in systematic deduction and testing of hypotheses and can evaluate the logic of verbal statements without referring to concrete situations. Children at this stage can understand logical concepts such as if-then statements, such as if I'm late for school, I'll get sent to the principal's office. And they can understand either-or statements, such as Mom says I can either go to the game tonight or go to the sleepover tomorrow night. And they can also begin to think about pretty abstract questions like the meaning of life. Piaget opened up a new way of looking at how children's minds develop. We owe him for a long list of concepts that have enduring power. For example, for the currently accepted vision of children as active, constructive thinkers who play a role in their own development. Now, in evaluating Piaget's theory, it was noted that not all people reach formal operational thought, and his theory does not extend into adulthood. There's no real theory of what occurs after the onset of adolescence. And the theory doesn't sufficiently consider the impact of culture and social environment on cognitive development. However, recent research has shown that cognitive development seems to proceed in the general sequence of stages that Piaget proposed. Piaget did not think that culture and social environment play important roles in children's cognitive development. For Piaget, the child's active interaction with the physical world was all that was needed to go through these stages. The Russian psychologist Lev Vygotsky took a different approach. He stressed that cognitive abilities develop through interactions with others and represent the shared knowledge of one's culture. One of Vygotsky's most influential notions was developmental readiness for learning. He identified the zone of proximal development, which is the difference between what a child can actually do and what the child could do with the help of others. It's the phase when children are receptive to learning a new skill but aren't yet successful at it. He suggested that for any given skill, children move from a phase when they can't learn it, even with assistance, to the zone of proximal development, during which they're ready to make use of scaffolding. Scaffolding is a term borrowed from building construction. Just as builders provide external scaffolds for support while building is underway, parents provide a structure to aid their children. Over time, parents gradually remove structure as children become better able to complete tasks on their own, much like the training wheels on a bicycle. The last section of the lecture looks at moral development and social development, and we'll begin with Lawrence Kohlberg's theory of moral reasoning. It was built on earlier Piagetian theory and he used a series of stories that involved moral dilemmas to assess a person's level of moral reasoning, and he discerned 3 levels of moral reasoning. Kohlberg began his study of moral thinking by asking children, adolescents, and adults questions about a series of stories. One of the stories goes something like this. A man, Heinz, whose wife is dying of cancer, knows about a drug that might save her life. He approaches the pharmacist who has the drug, but the pharmacist refuses to give it to him without being paid a very high price. Heinz is unable to scrape together the money and decides to steal the drug. After reading the story, the interviewee was asked questions about the moral dilemma. Should Heinz have stolen the drug? Kohlberg was less interested in the answer to this question than he was to the response to the next one. Why? Based on the reasons people gave for their answers, Kohlberg evaluated their level of moral development. Kohlberg identified 3 broad levels of moral development: pre-conventional, conventional, and post-conventional. We all begin at the pre-conventional level as children, and with development, people move up the ladder of moral reasoning. The sequence is uniform, but not everyone reaches the post-conventional level. Kohlberg linked moral development strongly to cognitive development. In addition to developments in cognition, he thought that advances in moral development occur through chances to discuss moral issues with a person who reasons at a stage just above one's own. For Kohlberg, a sense of justice was at the heart of moral reasoning, which he believed laid the foundation for moral behavior. Let's take a look at these broad levels. At the pre-conventional level of moral reasoning, there's an emphasis on avoiding punishment and looking out for your own welfare and needs. Moral reasoning is self-oriented. Going back to the story of Heinz, reasoning is guided by not wanting Heinz to go to jail or by concern for the pharmacist's profits. At the conventional level of moral reasoning, emphasis is placed on social rules and laws. Social approval and being a dutiful citizen are important. The individual abides by standards learned from parents or society's laws. At this level, the person might reason that Heinz should act in accord with societal expectations or should follow the law, no matter what. At the highest level, the post-conventional level of moral reasoning, the emphasis is based on self-chosen ethical principles. Human rights take precedence over laws. Self-condemnation for violating such principles is avoided. The individual recognizes alternative moral courses, explores options, and then develops an increasingly personal moral code. At this level, the person might reason that Heinz's wife's life is more important than a law. There have been criticisms of Kohlberg's theory. You might have noticed a particular limitation was Kohlberg's emphasis on cognitive reasoning, that a person can know the right thing to do and yet might act in an immoral way. He studied moral reasoning and not moral behavior, and he may not have adequately represented the morality of women. More recently, psychologists interested in moral development have emphasized that Kohlberg neglected the influence of gender and culture morality. Because of its central role in how we relate to each other, culture influences the ways individuals navigate moral dilemmas, and the higher stages may be biased toward Western cultures. Attachment and parenting styles play a role in social and emotional development. Just as infants require nutrition and shelter, they need warm social interaction to survive and develop. Attachment represents a lifelong emotional bond that exists between infants and their mothers or other caregivers. It's formed during the first 6 months of life. Why does attachment form? A classic study by Harry Harlow demonstrates the essential importance of warm contact. Harlow separated infant monkeys from their mothers at birth and placed them in cages in which they had access to 2 artificial mothers. One of the mothers was a physically cold wire mother. The other was a warm, fuzzy cloth mother, the contact comfort mother. Each mother could be outfitted with a feeding mechanism. Now, half of the monkeys were fed by the wire mother and half by the cloth mother. The infant monkeys nestled close to the cloth mother and spent little time on the wire one. even if it was the wire mother that gave them milk. Now, when afraid, the infant monkeys ran to the comfy mom. This study clearly demonstrates that what the researchers described as contact comfort, not feeding, is crucial to the attachment of an infant to its caregiver. Types of attachment have been studied. Mary Ainsworth devised a way to study differences in children's attachment called the strange situation test. She observed infant behavior in an unfamiliar room with toys while the infant's mother or caregiver and a stranger move in and out of the room in a structured series of simulations. She found 4 types of attachment relationships: secure, insecure ambivalent, insecure avoidant, and insecure disorganized. Ainsworth used the term secure attachment to describe how infants use the caregiver, usually the mother, as a secure base from which to explore the environment. In the strange situation, the secure infant is upset when the mother leaves, but calms down and appears happy to see her when she returns. Infants who are securely attached are more likely to have mothers who are responsive and accepting, and who express affection toward them than are infants who are insecurely attached. The securely attached infant moves freely away from the mother, but also keeps tabs on her by periodically glancing at her. An insecurely attached infant, in contrast, avoids the mother or is ambivalent toward her. In the strange situation, such an infant might not even notice the mother has gone, or conversely might respond with intense distress, only to rage at the mother when she returns. Diana Baumrind identified the following major parenting styles: authoritarian parents who tend to be strict with their children, giving their children little opportunity for free play or exploration, and punishing them when they don't respond to their demands. They show little affection toward their children. Authoritative parents are supportive of their children but set clear and firm limits with them. Permissive parents tend to be lenient with their children, allowing them considerable freedom inside and outside the household. They use discipline sparingly, if at all, and often shower their children with affection. Now, some authors refer to these 3 styles as too hard, too soft, and just right. Now, Baumrind found that children with authoritative parents exhibit the best social and emotional adjustment and the lowest levels of behavioral problems. In terms of social development, a developmental milestone is the children's ability to understand that others' perspectives can differ from theirs, a capacity called theory of mind. Theory of mind refers to the children's ability to reason about what other people believe. It involves understanding of the mental and emotional states of both ourselves and others. And research suggests children typically do not develop this before the age of 4. It may have a biological basis in mirror neurons, and some research suggests or contends that children with autism do not seem to develop theory of mind. The lifespan development theory of the influential psychologist Erik Erikson proposed 8 psychosocial stages of development from infancy through late adulthood. In calling the stages psychosocial, Erikson meant to emphasize how a person's psychological life is embedded in and shaped by social relationships and challenges faced by the developing person. It emphasized the impact of society and culture upon development, and divided the lifespan into 8 stages of development, each with a major issue or crisis that has to be resolved. Each stage is named after the 2 sides of the issue relevant in that stage. It led to an increase in research on lifespan development, and it's also been criticized for the lack of solid experimental data to support it. I've reproduced a chart from the text which shows each stage and the age range and a description of each stage. From Erikson's perspective, each stage represents the developmental task that the individual must master at a particular place in the lifespan. According to Erikson, these developmental tasks are represented by two possible outcomes, such as trust versus mistrust in the first stage. If an infant's physical and emotional needs are well taken care of, he or she will experience an enduring sense of trust in others. If, however, these needs are frustrated, the person might carry concerns about trust throughout life, with bits of this unfinished business being reflected in the rest of the stages. For Erikson, each stage is a turning point with two opposing possible outcomes. One, greater personal competence. The other, greater weakness and vulnerability. Now, his theory is important because it extended past adolescence into the stages of adulthood, and it played a major role in leading developmental psychologists to focus on the entire lifespan.